Hi all to the concept of linear programming. So today's class will be on linear programming. Okay, so linear programming or linear optimization. This is also known as optimization. So basically today we are going to optimization. Yeah. Okay. So today we are going to deal with concepts. So till now we have learned that whatever are the equations of straight line, for example y equals to mx plus c, we already know that this is representing nothing but a straight line where this is a variable and this is one more variable. And what is this m and c? M is known as the slope of a line and the c is particularly known as the y coordinate. Okay, so what do we mean? For example, if I draw a line like this, right, so then can you see whatever the line is making with the positive y-axis over here, right, from the origin, and whatever the intercept it is making, this is known as the c value. So clearly from over here, can you see that the c value is above origin, so this will be positive c value. But there might be a line which looks like this, so this will have a c value which is negative c value, right? So because why? Because this is below origin, so this will be a minus c. So depending on that, the nature of the graph changes. Okay, also what is a slope? So we already have the concept of slope in equation of straight line. If not already done, then we will discuss it later on. But okay, so what is a slope? So basically it is nothing but a tan theta. Okay, but what is tan theta? What is theta? For example, I have a line like this. So this is y and x-axis, right? So we have a line like this, any line, it doesn't matter what is the equation of this line, we just have a line like this. Okay, and whatever this line makes with the positive x-axis, understand very clearly, what angle this particular line makes with the positive x-axis is this angle, right? So tan of that angle will give me nothing but my slope. So this is my slope over here, which I have got that tan of angle theta is nothing but the slope of this curve. Okay, so it is also defined. Okay, so what is tan theta? It is nothing but in a right angle triangle. What is tan of the angle theta? So it will be nothing but height by base, right? And this is the hypotenuse. So it is height by base. So over here, can you see in this line, if we draw our imaginary 90-degree in this triangle, in this Pythagoras triangle, if we draw a right angle triangle, so can you see that tan theta will be nothing but this is the height, which is nothing but change in y, and this is nothing but the base, which is change in x. Can you see x-axis and y-axis? So tan theta will be given by nothing but change in y by change in x. And why do I say change in y by change in x? Because we are always considering 2 points between which we are trying to find out the angle. And see, whenever we are considering 2 points, this is one more line. So can you see that this line and x-axis are parallel to each other? So obviously these angles will be corresponding angles. These two angles will be corresponding angles. So I hope it is clear, right? So these concepts of parallel lines and all those things will be coming on in subsequent chapters, but so we need to be very careful. So just giving you a brief. So we have two parallel lines. If we have two parallel lines, and any line which cuts through the middle is known as a transverse. So what happens to a transverse? So we have two types of lines, two types of angles. One is known as the corresponding angles. So these two are known as the corresponding angles. Whatever is above the line is known as something called as corresponding angles. And conversely, so this one and one is known as vertically opposite angles. So all of these are equal. So can you see that clearly? One is below this and this. So these two types of angles are known as alternate angles. So we have three types of categories. One is known as alternate angles, right? So one is known as alternate angles, one is known as consecutive angles, and one is known as vertically opposite angles. So these three, so I hope we all have a concept of these three in parallel lines. Okay, and parallel lines are represented by these arrows over here. Okay, so coming back to our topic, so slope was defined as delta y by delta x, which is given as tan theta, which is given as m. So in an equation, general equation of straight line, y equals to mx plus c. So this m represents the slope, c represents the y-axis. Okay, and how to plot these graphs? If there is an m which is positive, so it will always be tan theta, which is acute angle. So theta will be acute angle, so it will be something like this or this or this or this, but it will be within this 90 degree, so within this first quadrant over here. Why? Because theta is less than equal to 90 degree. Tan 90 is undefined, right? So but before that it exists, right? So we know the graph of tan always looks like this. So this is the graph of tan and this is 90 degree. So for 90 degree it is undefined, it is going towards infinity. But from 0 till 90, so the values are defined. So basically we are trying to define that for all positive values. So can you see that clearly? for all slope which are acute angle, right? So this is the acute angle. Can you see that this is angle acute, this is angle acute, this angle is acute. So all these acute angles are creating a tan theta which is giving you a positive value. So these slopes are positive. So whenever we have something of a positive slope, so what happens? So this is my angle. So we know that, okay, the value of tan theta is positive, theta should be acute angle. So we are expecting a line to look like this. Okay, but now what happens if my tan theta is negative? So if my tan theta is negative, we know that theta is an obtuse angle. And what do we mean by obtuse angle? Something which is greater than 90 degrees known as obtuse angle, right? So which lies between 180 and 90, right? So 180 and 90 is known as obtuse angle. So x should lie between greater than, so it should be, less than 180 and greater than 90. So this is the definition of obtuse angle. So obtuse angle, so we know. So how does it look? If I want to give you an example, obtuse angle looks like this. So this is an obtuse angle in a triangle, right? So I hope it is clear what is an obtuse angle. But okay, so let's move forward. So for having tan theta is negative, then what will be my point of concern? If my tan theta is negative, then my slope will be negative. So what do we mean by negative slope? That my theta is obtuse, right? So if you have y-axis over here, x-axis over here, then what happens? Where should my angle look like? So it is an obtuse angle, you are saying. Always, when we are making a slope, it is always from the positive x-axis going towards the left hand side. Okay, so this is how we calculate an angle. So this is an angle, this is an angle. So we'll always start from the x-axis, positive end of the x-axis, and go towards the other end. Okay. So if you have an obtuse angle, so your line will look like something like this. So can you see, previously your line was looking something like this, which is having a positive slope, m positive, but this is having a negative slope. That is why it has reversed itself. So this is looking like this. So this is your general concepts of how we plot a line and what we do with a line. So in the next chapter, we'll look into like plotting one of the equations of straight line. We'll take a straight line equation and we'll try to plot them. Thank you.